Hello everyone and welcome to lesson I think 19. I think at some point I missed the actual counting and I messed it up, but this is I think actually lesson 19. So welcome back to the dojo, samurais, and today I have a very special lesson where we will be creating a package in R. This will allow us to, if we're reusing a lot of the functions and a lot of our code in multiple scripts, instead of updating that function in every single script that you create, you can actually create a library. In this library, you can create it yourself and you can install it locally, use it just for yourself, share it with your colleagues, and these will make sure that things remain consistent, right? So that's the topic we will be covering today. Okay, how to create a library, and then at some point we'll do lots of things. We might even go into modifying the first Shiny app we created and update that with some of the functions. So we'll be referencing our first Shiny app, copy some of the functions there, and those functions we will use in our library. So it'll be a very short library. Okay. Okay. With that said, let's start. I think we can probably. Let's open it up. Okay, so I opened this one. I'll keep that one open, but then I will create here a new project, and then here you should select a new directory, our package, and I will make this big at some point. Just bear with me while I create the package. So we'll call it I will call it MFP. So my first package, MFP. And where do I want to? Let's go into. You see, I this is where I work. Let's call it here. Let's do it here. Open. Okay. So here, MFP in class, and then let's check this. Create a Git repository so that we can version control that, and then let's click create project. Now once we've created that project, we should have here something called MFP, and it already has lots of folders. It has something called man that is having some hello.rd uh, stuff, a namespace, description, and R where you have your R function. So this is the general content of our package. Okay, there's a few things we need to do before we can actually create and manage a package, because we'll be using lots of different libraries. So make sure that you install the following libraries, and I'll type them on the screen. So you will need the library use this. Actually, let's do it here. So go to packages, go to install, and make sure to type here use this, install this one. Then you also want to install Roxygen 2. So install this one too. And then DevTools is the last one you want to install. So we will need all those three for making our package. Okay, so make sure you install them. Once you have them installed, then we can continue. Of course, I will assume that you can pause the video if you want. Do it and then proceed. I'll just continue. So let's press cancel here. And I will just, yeah, I'll just go here to files. We have our stuff in here. And you have here in your R folder, you will have all the functions, all the scripts. Every script should be a function, right? Like here, you have hello function, print hello world. So what I will be doing is I will be creating a function that is based probably on, let's see, our Shiny application. Yeah, sorry, I opened something else. Uh, okay, we have this hello world here, and then we will be looking at, sorry, I need to go into our class folder. Here it is. Yeah, I will be copying some of the functions we had here. So if you remember, we had this function called plot graph one function, and then another one called table, and then another called Excel export. Yeah, so we'll be taking all these three functions and making scripts out of them, or maybe I just take two to not make it too overly complicated and drag this for way too long. So let me copy plot graph one, the whole thing. Let's go back to hello. And here, hopefully you loaded the library called use this, because we will be using a command for that. We will type use r. Actually, I need to load it. Use r. And here I will type the name of the function. Let's call it graphing. And then just press enter. And then it says here setting active project to this. Modify our graphing.r, and then we have here our function called graphing. If we open it, it's completely empty. So we'll have to start filling in some stuff in here, right? And to do that, well, first we should probably copy our function. So let's go back into our app. Oops, sorry about that. Oh, it's not letting me copy it. Interesting. Let's see, Control Command C. Nope. Okay, that is unusual. Let me see if I can close it and reopen it. It should be working. I don't know why it's not letting me copy. Ah, now it's working. Strange. Okay, copy that. Let's paste it here. Now we have our function copied here. Now this is very important. We're going to insert what's called a Roxygen skeleton. Roxygen will help us basically create the documentation for our function, right? In a very easy way, so that way we can contain both the function itself plus the documentation in the same place. So you saw basically two folders here, one called man, which contains the documentation for the function, and then another one called r, which contains the function plus the Roxygen tags. Now, to insert Roxygen tag, you go into code, insert Roxygen skeleton. Now, if you click that, it'll tell you this error, like unable to insert skeleton, the cursor is not currently inside an R function definition. You click OK. That means that you need to be inside an R function, which is this. We have our function here. Make sure you're inside. Click anywhere, doesn't really matter. Then click code again, insert Roxygen skeleton, and then it should be working. Now you have several things here. We have a title, so let's call this graphing. We have some parameters here, which already come from these ones, right? DF, MPG, and cylinder. And we can basically say here that DF is a data, a cars data frame, MPG is a numeric, and cylinder is also a well, it's not really a numeric, it's a factor in there, but it's yeah, let's say what it is, a factor. So here you can add some description to that, right, to those parameters. But we can also add something called a description tag with description. And here we can say, or have a short description. This function graphs. Let's keep it very, very short. I don't want to make this very, very long. So let's say this function graphs, that's it. We know. And then we have here the word return. It returns a graph object, let's say, a plotly graph object. Export here, this tag word means that this function will be accessible to the final user of your library. If you don't want that to be available outside, you should probably just remove this word. Okay, otherwise it'll be available to the final user. In this case, we want it to be available, so that's why we have the export tag. Then here in examples, you can have examples that run. I'm very lazy and don't like really testing those examples. So usually what I do is I just type don't run, and here inside I just type, for example, plot graph, which is 1, our function, and then I just write df equal empty cars, for example, mpg equal, I don't know, 10, and then cylinder equal, let's say 4. I don't know, just in case. And this is an example of how you would use this particular function. Lastly, we need to provide something called import. So what kind of packages this function uses, right? So don't put tidyverse here. You shouldn't put tidyverse here because it's that's a meta package that contains many other packages, so you'll have to know which things you're actually using. In this case, I think we're just using Dippler. Did I type that correctly? Dippler? Let's look. No, it's not dbplir. It's Dippler. So actually it was correct. Dippler. There you go. Dippler. Then another at import. Let's call this one ggplot2 at import. We have plotly, and I think that's probably all we're using, right? Dippler. Yeah. Now, very importantly, when you're using packages here, it's usually better to avoid any sort of collision with functions with other packages, that you specify the package it's coming from. So you would probably need to do something like Dippler filter, something like this. I will not be doing this because I'm lazy and I don't want to spend a lot of time doing that, but you should. It's like you should be doing it. You should be specifying where things are coming from. Okay, I will not do it, but please remember you need to do it, and you do it basically how I just showed you it's done. We can probably come back at some point and test it out to see that it's actually how I told you it is later on in the lesson. Okay, so we have already our imports, Dippler, ggplot, plotly, and I think that's all we need for this function. So our function is probably complete, right? So let's save it. Then we also want to have another function, right? A function that does the table. We'll call it table1. So here we'll say use our table. Yeah, let's call it table. We have it here. We insert, and then we do exactly the same thing. Code, insert oxygen skeleton, and then we can just write here the rest. So what I will do is from df cars data frame, return a table, a DT table, a DT object, let's call it. And then examples, we will do the examples, same as we did last time. Let's just copy this. Don't run table 1 df empty cars. It's also export, and then we will do some add import, and we will type here again Dippler because it depends on that one. What else does it depend on? It depends on let's see what else we have here. DT. And probably that's it. Dippler and DT is what we would need. If we need something else, probably it'll complain, so we'll know about it. But I think it's probably like that. Title here, it's let's call it table, just like we called graphing. So we call it table, very imaginative, huh? Let's type the description. This function generates a DT table. Although DT, the T table is probably for table, so it's a bit redundant, but it's fine. Okay, so we have everything here. We have the parameters, the return, export, blah blah blah. Great. Hello. I think we should probably delete this function because it's not really required. So let's actually delete that from our folder. Yeah, it got removed. Okay, so we have our graphing, we have our table, and then we need one more function, which is the Excel export. And we will do exactly the same thing. Use our, let's call it save. Yeah, let's call it save. We're going to save, we paste our code. Again, inside the function, it's pretty repetitive, as if you've seen. Insert oxygen skeleton. Examples, we do exactly the same thing. Let's go. Don't run. Here we say Excel export. df equal, I don't know, empty cars or something like this. Is just an example. And name equal I don't know, let's call it file 1. Now if I remember correctly, when we use the file save function, we pass down, yeah, it needs to be with the extension. Yeah, something like this, or it would look like our file save function. Or actually just file in there, but it's okay. I think it doesn't really matter. We have also our imports. and we need OpenXLSX. We know that. At import, we need Dippler. I think we need Dippler, don't we? Actually, no, we don't need Dippler. Brisbane. No, I think that's all we need, just OpenXLSX. So yeah, let's just leave it like that, OpenXLSX. Okay, great. Then let's save this. Export, we want to export this. This says return saves the Excel, saves the information as an Excel file. Title, save, let's call it save. Add description, saves information as an Excel file. So maybe our return should be an Excel file. Okay. So I think that makes it so that we have completed all our functions. Hopefully we won't have anything else. And then we can proceed to maybe generate some of those help files in the manual section. So here we should be having many more things. Okay, so how do we generate that? Well, we need to go to build, and here in more, let's click configure tools first, and let's click here generate documentation with Roxygen. Okay, so to have this available, please make sure that you did install Roxygen before going here. If you didn't install it, you won't see that in here. That's a common mistake. So make sure Roxygen 2 is installed. Then go into more, configure build tools, generate documentation with Roxygen. Just click OK. Okay, and that's fine. Now, probably if you run or build the documentation, here you'll have this option now called document. If you run it, probably will get some error. Yeah. So, yeah, we have a few. Yeah, it says save param requires 2 parts, an argument name and a description. Okay, so we didn't provide here a description for our stuff, so that's good. So df, let's say a cars data frame, and name a name for the file with extension. Great, let's save it. Let me try again, and probably it'll complain again. Yeah, it says here skipping namespace, it already exists and was not generated by Roxygen 2. So this is very easy to solve. This file over here, we'll just delete it. So we will go back into, actually let's go here, let's remove here our hello.rd because it's not needed. You notice that we have some other files, and the namespace, let's just delete it. Let's regenerate it with Roxygen. So we document again. Now it'll say it's complete and we have a new namespace. Here in the namespace, you'll see everything that is required, and it's read-only. You can only modify this through the functions that we have. So we have dt, dippler, ggplot, openxlsx, and plotly here. Okay, that's what we have. Then what else do we need? I think that's fine here with the namespace. Great. What else do we have here? We have some stuff called description. In description here, you have a lot of things in here. So we can actually go through some of those things. Package is the name of the package. It's called MFP. Type, it's a package. Title, what the package does. Let's just call it my first package. I don't know. Version, and then author, who wrote it. For author, we will be doing a little bit of a change here. We're gonna be typing author here, modifying it with an at R, I believe. And let's add here actually authors at R. And who wrote it. And here we will be typing some additional information. We will be typing person. And here it'll be our SamuRai lab. here you can write your name. Then we'll type the, let's say, email address. Then we will type what's the role. In role, you can have the author and the maintainer with Cree. Cree is the maintainer, so it could be the same. In this case, it's both. Our SamuRai Lab is both the author and the maintainer of the package. We add a comma, some space, then we type comment, and here we type equal C or ICD. Wait, it's or CID, sorry, or CID equal our SamuRai Lab. And what do some of those things mean? You might be wondering what that means. And let's see, org ID. Well, it's basically a unique identifier that associates this work with ourselves. So you can type anything here, but that's about it. Okay, sorry for that. Then I think that should be done with that. Then the package maintainer, the package maintainer. So let's type here our SamuRai Lab. At gmail.com. I think that should be it. Then description contains the functions for our first package, let's say. We don't need to have a very great description there. And type of license, there's several types of license. I will just say here MIT, but there's multiple ones. You can look it up online as to what type of licenses there are. Encoding, leave it as UTF-8. Lazy data, leave it as true. And then Proxygen node 7.3.2. Now we can add some additional things here. We can add in here something called depends. And this is basically, we can specify the version of R it depends on. In this case, it would be version 4.4.1. So let's say greater equal to 4.4.1. And then we can also add some dependencies to some of the other packages, which we can add either by typing here or by using use this package and type use package. Use package, and here we'll type, for example, Dippler. So it says now imports Dippler. Wait, give me a second, because I could have used. You can also specify, for example, Dippler, and then the min version. We can make it to the minimum version here, for example, 1.1.4. Yeah, like this. Right, so you can also specify that in the use package min version. What else do we need in this application, in this package? Well, we can see we use OpenXLSX, right? So let's look at OpenXLSX. it goes. Ooh, 4.2.7.1. So I'll just forget about the min version. Of course, you should be specifying a min version. I will just be doing it very, very quickly. So I will just type open XLSX as to not take too much of your time. But remember, you need to specify, you should be specifying a minimum version. So open XLSX, it'll work here. Then let's do it again with, I think it was ggplot2. Then we have plotly. And then I think our app contains many other things, so we will be using that library here. So maybe we want to add, no, it's okay, we can just leave it like that. Let's not add dependencies to this. So we use what? Let's see. OpenXLSX DT Dippler. Plotly Dippler, okay. So DT, we're missing basically just DT. So let's do that again. Plotly, instead of plotly, let's just type DT. And there we have it. We have Dippler, DT, ggplot, OpenXLSX, and plotly. Remember, you should be specifying the minimum version to make your package actually not break if something is a much earlier version. That's what I recommend. So it'll give you a warning. And let's do that again, document. Okay, so that documentation has been completed. That seems to be working all fine. We still haven't installed the package. What else do we need to do here? We can also include an application inside our package so that we can run it from there. So we will be also doing that, just in case you ever wonder how you can do that. So what I'll do is, we have here our folder. So I'll create a new folder in here called inst. And this is where we'll be placing some of our applications. Okay. So let's go inside inst. Let's make another folder called application. Then inside the application, let's make a new folder. Let's call it empty cars. That's the empty cars, let's call it. And this is where we will be placing our application. Okay, so let's go a little bit back. Let's go into my first Shiny app. Let's copy our application. We have our application, but that doesn't mean that we can run it. So we've set up now the thing on how it should work. Now we need to actually have a function to execute that Shiny application, right? So that means that we need to create yet a new function. So, oh, this is strange. I'm pretty sure there's only one. Yeah, there's only one. So let's go back to R and then let's use this. Use R, actually use R, and let's call it run app. Yeah, let's just call it like that. Okay. And here we need to provide again several things. We need to create a function. So this one I'll be typing myself. So let's call it run app. Empty cars. It's a function, and it'll be taking, or it'll be doing something. So it'll be after we'll do then system file, system.file, then the name of our folder, which is application, and then we have that in what was it called? Application empty cars. Yeah, so our folder is called empty cars. And then the name of the package, which is MFP, is gonna be our package, my first package, MFP. Once you have that done, we'll make sure that we have some kind of if statement in case our application doesn't exist or is not included in our folder or something for some reason. You should be including it. So we'll do something called stop and could not find application directory. Try reinstalling package MFP. Call that false. That should be set. And then if this doesn't happen, then we just execute shiny, run app there, display mode equal normal. We have that done. Now we need to, of course, generate the Roxygen skeleton. So let's go to code, insert Roxygen skeleton. Let's call this empty cars application. Let's add a description. The description should be runs empty cars application. There's no return, so let's remove the return. It's an export because we want, and then we need to type in here again our example. I'll just copy this here. Don't run Excel export empty cars name file. Actually, it's not here. It's just run app empty cars. And you don't need to provide anything. It's a function that doesn't take any arguments. It does need shiny. So let's add that in there. Import shiny. Let's save this. I think that's pretty much done for our application. We'll see how that runs. Okay, so we can probably close it. This one I will close. We'll probably open it at. Actually, we have a new version of that in empty car, so we'll do some modification on that a little bit later. Okay, so we have import shiny again. If we go to MFP to our namespace, we will probably see at some point here the shiny stuff. So let's regenerate that document. Yeah, we see import shiny, but we're also missing in our description. We want to add that dependency, right? So let's type use package shiny. There we go. I didn't specify again the minimum version. That's something that you should definitely do. Okay, and that's probably all we need to do for that. All we need to do for that. But we're still missing some things. And I know this is probably gonna be a long lesson, so I apologize for that. I'm trying to go as fast as possible. Trust me. We can still do one more thing. We can add here some data. We can include some data with our package, and for that you can create a folder called data. But for that data, we need to do quite a few things to make it work. So let me just create a new script here, and let's go to the environment. So first we need the data that we want, right? If you have it here, you can just save it as a .rda. In this case, I don't have it here, so I'll have to load some of that information. So I'll just take from the application. If you remember, a long time ago we commented this code out, so I can just probably use this. Just to import that, let's call it, I'll just call it cars, okay? Cars. I could not find, so that means I need to load Dippler. Actually, I'll just load the whole tidyverse. Okay, so we have now our stuff here. We still don't have it saved. So I will just type in here save cars, and then cars.rda, because RDA is the way we're gonna be saving that. It's our data, basically. That's what it's saying. Object. Yeah, it should be. I hate when this happens. Okay, time to save data as RDA. I'm pretty sure I'm making a very, very silly mistake. Oh, look. Oh, file. I think that's what I am missing, huh? Yeah, that was it. Oh, thanks, Statology, for saving the day. So we have that, and probably it saved it. Yeah, it saved it over here. So let's go back to our main folder, and let's move that into data. Okay, so now it's in there, and we still cannot access this easily. So we need to have a way to access that data, and to do that we need to create yet another function that handles or manages our data. Now this can take me some time to type, so probably what I'll do is I'll create the function, and then I'll just copy and paste some stuff that I have on my computer so that we can accelerate that part. You can pause the video and just look at how I did that instead of going through all the things. Okay, so let's go again. Let's use R. Let's call this data. Now we have it there, it's open, and then the data handler is a little bit different. So I just copied and pasted something that I had on my computer, right? So that we can accelerate that part. It's important that you do it like this. If you have multiple sets of RDAs or lots of RDA files, and you only need one data controller, let's call it the data controller. You only need one data controller, right? So you can just basically copy this and paste it below and use it for something else. Right now, it's important that you itemize every single variable you have in your data. So if you have 12 variables, I should have 12 variables here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then you need to provide, of course, a doc type. It's data. The keywords is a data sets. Name of that is called cars. Usage data cars. and then a data frame with 32 observations and 12 variables is the format. Okay, so I will be deleting this and I'll be saving it. Okay, so that should have our data controller already working. Okay, so we've done actually quite a lot so far for this, but we haven't really, I won't save this, we haven't really created yet or built our library, right? So let's go to build and we'll just delete all this. Let's create document. So it'll generate those new documentations in the man folder. And then here comes the interesting part where we can basically install. I'll be closing this. Where we can basically install this in our computer. So let's first check that I don't have anything called MFP. I don't think I do. Nope, I don't. So we will need proceed to install. So here we can say clean and install. Oh, there's some error. It says, oh, okay. Let's see. Installing to library. Invalid description file. Okay, so I definitely did something wrong in the description. Oh, what a pain. Let's see. Maybe I didn't have to remove that. Maybe that was the case. Maintainer, let's call it our SamuRai. Let's try again. Authors are okay. Gives no with maintainer role. I think there's probably something wrong here in the person. Okay, give me 1 second, guys. I need to fix this. Oh, don't you love it when things go wrong? I sure do. I'll try to consult some of my previous work done for this in preparation for this lesson, because that was definitely that one was working. SamuRai, and let's call this lab. Let's try. Let's try again. Maybe I need to type another comma there. We have the role. Okay, let's try it again. Yeah, there we go. Okay, so it was basically I needed to provide something in here, right? So if I remove this, probably I won't be able to clean and install it again. Yeah, So we do need that extra comma there to place something else in here. Um, Probably a missing. Let's see if we can check. Yeah, I'm probably missing something here, but yeah, just add this one thing in here. I would probably need to check exactly what that is, but I don't want to waste your time. Um, just remember to add that in there, and then it should allow you to clean and install it. See, it says done MFP. So now if we go to packages, we should see something called MFP. MFP, my first package. There it is, version 0.1.0. So that is working now. Before we load our package and do some of those testings, let me go. Actually, it's already loaded. So let's test if our data is working. So if I type data cars, it says MFP, right? And I go to the environment. If I execute this, we'll see that now we have here our cars. Actually, we should be, well, it was a promise. Now it's there. You could also do, for example, df cars, and it also works. So either way it works, data cars or df, right? And it's basically the information we have. So our data is working. Right now we also want to modify our application, because we now have here a new dependency. We can say library. It's called what's it called? MFP. That's the name of our package. So we add that new dependency, and here we can definitely remove all this stuff, because we have functions called graph1 and table1, and also another one called Excel export. Let's save it. So our library does contain those functions, so that means that it should be, calling them from here. So we shouldn't be afraid of it not working. I'm also going to delete this over here. We don't need it. So I will save that app, and then I will clean this up. I will do the build again, clean install, just in case. Now our library is updated and everything. And let's try. If I type MFP, we can see Excel export, plot graph1, run app empty cars, and table 1. Right, so our functions are there exactly the name we had. Let's try to run empty cars. Okay, let's try to run that. So run empty cars app, we execute, and what we see is this. Boom, it's our application running, right? If I click browse here and I click here empty cars, I can click open, and it's working. And this application is basically running from there. Now I can basically just close it, and it's done. So our application stopped being executed. So it's running perfectly. Everything in our app is working as we expect. Now the last thing we can probably do or check when doing a package is saving it, right? You might want to update certain things, add new things, and that's where our Git module comes into place. So we have our Git module here, and basically you want to include all this stuff right into our Git. You don't need to include git ignore or dstore. You can if you want. Well, let's kind of include them, but you don't need to. And then you click here commit. Once you click commit, you'll see this screen pop up, and here you can use just, for example, version, I think it's called what, 0.1.0, was it? Let's copy this. MFP. Zero point 1.0. Yeah. So let's commit. Let's call this version 0.1.0. And let's add a comment. First version of my first package or library. And then you can click commit. Now you also have the button amend previous commit. So in case, let's say that I do another change and I don't think it's worthy of a increasing the version number, and let's say that I already had in the history here another commit. If I click this button, the previous version will be amended, right? It'll be overwritten. So I'll click here commit. You have nothing to amend, of course, error. So I'll create this, and then it just created everything. And that's it. There's a Git repository in here, and then if you go into commit again in history, you'll see that it's version 0.01, and it says basically there how who did that, right? And I'll probably have to edit out my personal email from there. Not great to have that in there. And that's it. You know, there's much more to Git that I will not be explaining. You can check out versions, you can merge branches, and many other things that you can do, but you need to set up a Git repository for that to work. In the meantime, you can just use the Git on your local computer to control all those changes. Okay. Now that's it. I think we've created the library. Everything's running nice. Uh, there's nothing more to. Basically, that's it. You know, once you know all the things that you've been learning throughout the course, making a library becomes quite trivial, right? It's just a few things here and there, like knowing that you need dev tools and Roxygen and all this kind of stuff. Oh, by the way, I'm still forgetting one important topic. What if you want to install this library on someone else, right? So I said how you can install it on your computer, which was with build, and also remember to always document. You can do a clean and install, and it'll install it on your computer. But more importantly, you have two options here called build source package and build binary package. Build source package will create a .tar.gz file that you can just, give it to the user, and then they can use it to install the application on their computer. How? I'll tell you how to do it. So let's build it first. Build source package. It'll build it, and then sources package written to blah blah blah. If we go to our folder, we go back, we will see that we have here mfp 0.1.tar.gz. It's there. So you can share this file with your colleagues to make use of your library. But how do they install it? For them to install it, there's basically two options: to type the command in the console to install the package, or there's the easy way, which is just basically going to package, install. Instead of repository cran, you choose package archive file.tgz.rgz, right? And here it'll just tell you, and oh wow, let's go to desktop, let's go to class, mfp 0.1.0.tar.gz, click open, it'll show it in there, click install, and then it's done. It's basically reinstalled, right? And this is the command I was telling you about. If you were to install it manually, you can use this command. You can type install.packages, the location of that tar.gz file, repos equal null, because we're installing it directly from a path, and type equal source. Why source? Because the .tar.gz is a source file. We said build source package. If you want to build a binary that requires compiling, you can just click here, binary package, and it'll do more work, and then you'll get a .tgc. But this will require some compiling as far as I know. So I'm gonna delete that. And I'm also going to delete this one. So there you go. That's how you do it. That's how you build a package in R. There's probably many more things that you can expand your knowledge in here, but this will give you all the basics that you need to build that package. And if we see, if we go to MFP, you'll see that all the documentation, if you followed all the steps, right, that you did, you will see that you have all those. You click it, you'll see the very nice documentation for where it says cars. Oh well, internal server error, that's interesting. Okay, that shouldn't be happening. Let me clean it. Let me document this. And actually let me close this, and let's just open my first script. Just when you think I'm done, this happens. There you go. Now it's working. I don't know why it didn't work, right? But if now you can see that it's working. All our functions are very well documented with examples and everything. So congratulations if you've been following up until this point. You basically created a whole package. We updated an app to make use of that package too. Then we included that app as part of our library so that we can run it if we just type library mfp. Then we type run, what was it, mfp run empty cars. It's here beautifully running. Right, you saw it earlier. We can close this, and that's it. There's nothing more, I think, to package. I think it's a very intimidating topic at first, like, oh, he's building a package, but it's actually not rocket science. Not if you've learned up everything up until now. It's just a little bit of incremental knowledge. With that said, I think that's it for today's class. We've come to an end. We will not be revisiting how to build a library. And by the way, if you want to uninstall your library, you can just go to MFP here and click uninstall package. Yes, and that's it. It's gone, right? It's been removed. So that's it. We've covered everything now. For sure, we have covered everything that I wanted you to know. So thank you for taking this class. I know it took us a little bit, an hour, 5 minutes or so, but thank you very much for following up until now. Now, what will we be looking at next class? Next class, probably what we will be doing is I'll try to visit Quarto, which is kind of like the successor to R Markdown. It's another open source library to create HTML files and reports and all this other stuff, and it does require a little bit of adjustment. So we will be revisiting R Markdown code and then adapting that into a Quarto document. So we'll be covering that topic next time. so that you have R Markdown and Quarto, and you can say you can handle them both. So be very excited about that, and I'll see you next class. So thank you for joining. As always, remember to like, comment, subscribe. Help me get blessed by the YouTube algorithm so that more people can learn R with me. With that said, class dismissed, and see you next time.